Hi there, this is Lucas, and this is my creative contribution number 4. So today I'll be talking a bit about um, a function and how to graph it. So this specific rational function is right here. And the first thing I did was find the vertical asymptotes. I did that by taking the denominator and equaling it to 0. And this is the answer I got. X equals -10 and x equals 7. So right off the bat, you know what, well, I'll touch on that information in just a little bit here. So after finding the vertical asymptotes, I found the horizontal asymptote. You can see I basically looked at the coefficient with the highest degree in both the numerator and the denominator, and this is what I got. I got 2x squared over x squared, and then I took the ratio from that and got 2 over 1, which gave me the equation y equals 2. After that, I found the x-intercepts. I did that by taking the numerator and equaling it to 0. By doing that, I came to two ordered pairs, a/0 and -3/0. So those are going to be my zeros or my roots. Those are the 2 points at which there are direct points that touch the x-intercept. Here's some other information. Actually, lastly, the y-intercept. I'll quickly explain how I found that. I did that by essentially just substituting every single x in my original function and substituting it for 0. So the answer of that is y equals 0.69, which the ordered pair is 0/0.69. And then just to get an idea of the direction of this graph and how it's going to behave, I made a quick number line here. I included both my vertical asymptotes of 7 and -10. And then I basically found any number that lies in each of these different sections on this number line to find out if the graph will behave in a positive or negative direction. So as you see here, I have a negative, a negative, a negative, and a negative. Those are the numbers I concluded with after plugging in -15 into the original rational function, and a negative times a negative divided by a negative times a negative is equal to a positive. So with that information, I know that when I graph this rational function, that essentially the graph or the function will behave like this. It'll, as it gets closer to -10, the y value will increase, but this part of the graph will never actually touch -10 because it's an asymptote. Now I did the same thing for the middle portion of my number line and found that a negative times a positive divided by a negative times a positive is a positive, which also signified that the graph will be moving from negative to positive. So it'll be moving in a positive direction as well. And then for the last segment of the number line, I used the number 10, and I plugged 10 in for each of these x's in the original rational function. And the numbers I got were all positives, which gave me a positive number, which tells me that the function in this portion is also going to increase as the x and y's will increase together. So there's my number line. I also included a couple details about the domain. The domain is all real numbers except for 7 and -10, which are the 2 points at which my vertical asymptotes are. And then there are no holes. And I know that there were no holes because I didn't factor, there were no common factors in the numerator and denominator that were canceled out. So here's an actual graph here. So as you see, number line's above, graph is right below. And you can see that this graph indicates the same behavior that you'll see on the number line. And it's just a little more accurate. So you'll see that my vertical asymptotes are in place. My horizontal asymptote is also in place, which is 0.69. You'll see it graphed right there. You can also see that kind of looking over here in this area, here I'm going to point over here, you can see how as my points increase, they'll get closer and closer to -10 without ever touching it. And I did use a test point. Actually use a couple different ones. Here's a test point of -15 right here. And you'll see that the answer that I got when I plugged in -15 for all the x's is 5. So if we go back up here to see if a test point worked, at -15, which we could say is right here, we could say that the graph is basically 5. And again, this isn't perfectly scaled, but as long as it's above the horizontal asymptote, which is 2. So horizontal asymptote is equal to 2, which is what this line is. So 5 is greater than 2, so it shows that my plots are in the proper spot and that they are in their proper boundaries regarding both the horizontal and vertical asymptote. Another test point I tested is 10, which is right here. And the point I got after plugging in 10 to the rational function is 0.87. So it'll be over 10 and then 0.87, which is right here, which looks good because it's below 2. But the function is still increasing at this point. So yeah, that's just a pretty brief and quick explanation on showing how when looking at a rational function, you can break it down, you can find your zeros, you can find your y-intercept, you can find both vertical and horizontal asymptotes, and by using a number line, you can find out how your function is going to behave. And that's that. Thanks for watching.